few days ago, I saw a news talking about the rainfall in France. Do you know that? No? Okay. Some of the flooding.
Yeah,
flooding. Yeah, yes. I don't know. This time is your rainfall season in France. No.
We don't rainfall. But usually in summer. Nowadays.
Okay.
In the south of France.
Okay.
They get a flood, but it's not supposed to be like that.
Yeah.
The weather is going mad.
Yeah, I see. Okay, so I think in the beginning I will talk about the rest of the signal processing. So I think in the last week we are showing you what is the filter, okay, from the simple filter to the and also the time frequency spectral analysis using a short-time Fourier transform. Okay, because the traditional Fourier transform is only can be applied for the sinusoidal, I mean the time invariant signal. For the time variant signal, I mean that the frequency will change with the time. Okay. So how can you deal with this kind of the time variant signal processing? So we are talking about the short-time Fourier transform, and also I would like to say, if you already know that in the last week we are talking about if this is the signal, okay, we may have the sampling frequency like this. Sorry. Okay, and if you turn to this is a time domain and this is a frequency domain. Okay, so the delta t will be the highest frequency in the time domain, but actually based on the sampling frequency theory, so what is the maxima we can find in the frequency domain? Half of that, right? So only half, maybe we can see. Okay, so this is the sampling frequency theory. Okay, Nyquist theory, and also we are talking about if you already have the truncation, only big T, the time period you can capture on your computer. So the minima frequency is here. Okay, and you should know that, of course, in the frequency domain, because right now we are talking about a discrete signal. So not only the time domain, but also the frequency domain is discrete. So in the frequency domain, the frequency spacing between the data is also the big T, the inverse of the big T. Okay, so I would like to conclude that truncation, the window of the truncation, control the resolution in the frequency domain. Okay, and in the time domain, the resolution control the maxima frequency in the frequency domain. Okay, so I think this figure already shows that the concept. So we are talking about the Heisenberg or the uncertainty principle. Okay, this is the trade-off. So you cannot hold a high resolution in the time domain, but also remain a high resolution in the frequency domain. This is a trade-off. Okay, so you need to find a balance between the frequency and the time domain. Okay, but right now, however, some of the advanced transformation, I mean, like the wavelet and also the Hilbert transform, Hilbert-Huang transform, can provide some of the insight of the frequency time spectrum. So in the last week, we are talking about this is the original signal. So we divided into the several different subgroups. Each group has their own frequency pattern. Okay, so this is the low frequency to the high frequency here. Okay, so you can find a different component originally inside of the raw data of this one. Okay, and Hilbert-Huang transform. I think this will be a little bit semi-experienced basics method, but however, it is very good for deal with the signal that have a very short and very instantly change in the time domain. Okay, so you can find I just have a plot show you that the traditional Fourier transform is only can be applied to the sinusoidal, I mean the time invariant signal. For the very short time variant signal, you should know that maybe we can use the wavelet and even the HHT. So this is the frequency domain. So this means that the wavelet or the HHT can be used to find a very short change of the frequency, okay, in the signal. But just as I said, HHT need empirical mode decomposition, what we call the EMD. This is the, I mean, the experienced best method. Okay, but however, I think some of the research apply the HHT to find a different pattern in the frequency domain. Okay, so this is the example for the time domain, frequency domain analysis. So this is the spectrum, this is the time, and then this is the frequency. So you can find the different composition of the frequency in a different time. Okay. So in this chapter, I will conclude that the 3 R's. So I think you already know that the rate, right? How fast you can sampling from the signal. Okay, so here you need to know that Nyquist frequency theory. Okay, and supposedly for the, I mean, in practice, we are trying to use the 10 times of the sampling frequency to capture the signal. Okay, this means that when you have maybe if you have enough sampling capacity and also the disk space on your computer, I would like to encourage you use the 10 at least 10 times of the sampling frequency. Okay, it means that you may have a much smooth signal. Okay, so I think in the end of the last week, we are talking about the resolution, because right now we are not talking about the time domain frequency. We are trying to quantify the amplitude. I mean, how can you determine that for the 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, if this is the continuous signal with the continuous amplitude, so how can you decide how many digits of the precision you can capture? Maybe 10, or only 2 or 3 or 4. So this is depends on your resolution in the quantification. Okay, so here this is an example. The range here is from the -10 to the 10. Okay, so if I only have a 3-bit resolution, so what does that mean? Only 2 power 3, only 8 steps for the quantification. So it means that in the red line, sorry, maybe not so easy to see here. So in the red line, you can find we divided 8 steps into the range from the -10 to the 10-fold, right? So you can find, I think this is a little bit ugly because only 8 steps can be used. But however, if you extend to the 6-bit, so what is that? 64, okay? So right now we have 64 steps from the -10 to the +10. Okay, so here you can find the green line. It's much better to describe the waveform, right? Okay, so this is the what we call the resolution for the to quantify the amplitude of the signal. Okay, but however, in the beginning of this class, we are talking about the fs. Anyone know that what is the fs? And also the resolution. Fs means like the full range. Okay, so don't forget full scale. In the last time we are talking about full scale, and here we are using the range. I think this the same words. Okay. If you are talking about the resolution, you need to know that your measurement range. So here, if you use the 10 to -10 with the 3-bit, okay, I think this is very ugly. Just you can find here in the red line. But however, if you change to the 2 - 2 as a range, and also use the 3-bit to quantify the signal, I think it will be much better, okay? Because we are narrow down the range, so the resolution should be higher, okay? So please remember that you need to concern the range and the resolution together. Okay, here give you some of the example. I don't know, is there anyone still listen the compact disc? I mean the CD. Anyone? No, no one. Right now, MP3 or what is the most popular app you use for listen to music? Huh? Spotify. Okay, I also use the Spotify. Okay, but I would like to say in the left side, this is the spec of the compact disc. I have a questions that, do you know? I think you may know that for each CD, the longest time it may be about the 70 minutes. Do you know why? Only 70 minutes. So in that time, why it is much larger, maybe 100 minutes or 2 hours. So why 70 minutes? Maybe you can find the answer. Okay, Google that in the break time. But I would like to say in the left side, this is the spec of the compact disc CD. The CD uses the 44K hertz of the sampling because they're trying to capture the low frequency to the high frequency, okay, into the disc. And also use the 16-bit for the amplitude quantification. So here you can find the red line is the original signal, analog signal. And for the step, this is the digital one. Okay, to the next generation, because some of the hi-fi, I don't know in the French, I mean that buy a very expensive equipment to listen to music. Okay, they are trying to have higher quality of the compact disc. So in that time, I think we have a super compact disc and a spec up to the 24-bit. Okay, in the amplitude quantification. So you can find this is a much smooth compared to the 16-bit. But actually, I get my first compact CD after I graduated from the elementary school. Okay, about the 1992. Okay, 1992. Okay, I'm born in the 1980. Okay, so in the 1992, I get the first disc of the compact disc, and to the senior high school, I forgot that. There's some of the VCD. Do you know that? No. And the next is DVD. Okay. So here, in the right side of this chart, this is the spec of the DVD. Okay, up to the 96K hertz of the sampling frequency. Okay, but I know that right now you also can see the BD Blu-ray disc. Okay, actually, in my childhood, we see the movie or the television using the video tape. No one used that before. Okay. And I also listen to music with a disc. I mean a tab, a tab. Okay, okay. But right now, some of in my age still like the tape, the quality of the tape, because this is actually the analog signal, okay, not the digital one. So, however, I would like to say this is an example from the CD to the super CD and to the DVD. And also you can find the spec of the BD by yourself. You can find how much the sampling frequency it is, and how much of the quantification, I mean the resolution. Maybe still 24-bit. I'm not sure. Okay. Oops. Sorry. I'm so sorry, here is in Chinese, but I like to say, based on the idea of the 3 R's, I would like to ask all of you, if you have a project and only have a limited budget, and if you try to capture, for example, the vibration of this building in a different direction, I mean X, Y, and Z. For example, the earthquake, the frequency of the earthquake range maybe from the several hertz to the 20 or 30 hertz. So maybe we need to capture the vibration of the earthquake in this building. So based on this requirement and this objective, how can you apply the idea of the 3 R and buy the equipment that what we say the DAQ, the data acquisition from the analog to the digital conversion purpose? How can you buy that? What is the spec you try to find and you need to know? So here I just showing some of the different kind of the DAQ from the data logger here. Today we are showing the data logger. Okay. This is a data logger, and I mean that inside it always embed a CPU. Means that you can have a program inside for the control the data logging. And also we can use the second one. This is the industrial PC. Okay, just like PC, but have a higher temperature resistance and can be used in an industrial area environment. But however, this kind of the PC is a very power consumption. Okay, and for the third one, this is the a chip embedded on the board. Okay, this is maybe what we call the embedded system single board computer. Okay, less power consumption, but only the board. Okay, so right now the Raspberry, okay, something like this, what we call a single board computer. And the next is the Fpga. Okay. This is the electrical circuit that can be programmed. I mean that for the traditional electrical circuit, it is already fixed for some purpose of the electronic circuit. But however, for the Fpga, maybe you can find Google it by yourself. It is the field programmable gate array. Okay, so it's mean that you can program the electrical circuit, I mean the hardware, for some of the purpose. And of course, it means that the Fpga has higher computing capacity. Okay, so for some of the very advanced signal processing, we may use the Fpga, but of course, it is very expensive. It is very expensive. For that one, maybe 70 to 80,000 NT dollars for that machine. Okay, but for the Fpga, maybe more than 100,000. 100,000. Okay. So later I will show you how to control that the data logger. This is what we call the CR1000 from the Campbell Scientific. Oh, sorry, I forgot to. Okay, this is I think the biggest company in the world that provide the data logger and some of the sensor. So you can Google that. And I would like to say, if you are engineer and if you already have a project, just as I say, and only have the limit budget. So if you try to capture the earthquake vibration behavior in this building in the street direction, okay, right now maybe you need to capture the vibration behavior. So what is the best requirement from the idea of the Nyquist frequency? If you already have this requirement for the monitoring, okay, how much sampling frequency should you need? 60. This is the at least requirement, right? But I would like to say for the in the practice, maybe 10 times of the frequency, sampling frequency we should use. So maybe we need to use up to the 300 at least. But I would like to invite all of you, okay, guys. First, when you try to survey a hardware, the first rate, this is the rate you need to concern first, right? So for this kind of the data logger, because this is just only for the maybe some of the static behavior monitoring, not the dynamic behavior. So this kind of the data logger only have 100 hertz sampling frequency. But however, they provide several channels. Okay, you can find here, this is a lot of channel for the analog input. And also here you can find, this is the resolution, 13-bit of the amplitude quantification. Okay, and what is the range here? From the minus to the positive 5 DC. So we already have these three, the 3 R's, basics of the sampling from, and also the resolution and also the range. So can we determine that this kind of the data acquisition system is good or not? Okay, so I would like to left the questions for you. If I need to capture the behavior of the earthquake in this building, can this kind of the hardware suitable for your project? Yes or no? Okay, yes or no? And this is the higher level, higher end of the data acquisition. Right now you can find the first, this is the rate up to the 100,000 hertz. Okay, and where is your accuracy? Here, resolution 16-bit. Okay, and where is the range? Here. Okay, this is the range. Seems like it is much better because it has higher sampling frequency, right? Up to the 100,000. But here I just say maybe this is the NT, maybe NTD about 80,000, 80,000. But for this one, I don't know actually, but I think maybe 5 times, 5 times of the 80,000. Okay. And here, I'm so sorry, I forgot to bring this one. Okay, I should later. I should go back to bring. Here, this is the NI National Instrument. The product, what we call a USB. Here you can find the resolution here. For example, 6008 type with 12 resolution. Okay, 12-bit resolution. And for the rate here, it is about 150 hertz. And what is the range? Okay, later I will show you the range. I think maybe up to the 10K. Okay, not show here, but you can find the spec, detailed spec, just on the internet. You can Google that. And here I would like to show you. This is another DAQ. Sorry. This is another DAQ. Okay, this is the Aden 4118. Okay, this is also the A channel for differential signal input. Okay, and the voltage range, it can be adjusted both from the 50 millivolt to the 2.5 volt. Okay, this is the range. And also, this is the sampling rate up to the 100 hertz. And the resolution is about the 16-bit. But I like to say the previous two kinds of the data logger here, you don't need any computer because this is a standalone. You can have the program directly inside of this, what we call a small computer, the CPU, but very low computation capacity. But however, for this kind of the USB and also that one add-on, you need another computer. Okay, you need another computer with the program to control the USB and also this add-on. And in the last homework, we are talking about the IS-48 and also the IS-232. This kind of the protocol use the IS-48 485. So you can use the only single transmission line and has the many module of this together. Okay. And final here, I think this is the board, a DAQ board like to maybe install on the computer or the PXI, NIPXI. It is a specified computer, okay, and have some of the space for the different slot, Okay, so you can have a different of the module. So for this, the resolution up to the 24 and the sampling rate. I'm so sorry. Here, what is the sampling rate? Sorry. I think this rate may be up to the also 10K. 10K. Okay. So for this kind of the signal, I mean DAQ, data acquisition module, you can use for the higher sampling frequency purpose. Okay, and this is the what we call the Fpga, field programmable gate array. So this electrical circuit can be programmed on your purpose. Okay, so you've already know about how to write a program. Right now, we just have some code on our computer, right? And using the CPU for the calculation. But for the Fpga, it directly use the hardware circuit for some of the calculation. So it means that the computation is very, very quick and very, very fast. Okay, and of course, right now, we already show you the single board with the limit function from the Arduino. And this is the same using the Arduino base, and this is the linking one. Okay, and right now the Raspberry has the 4 generations. Okay, so this kind of the single board is much suitable for the image processing. Okay, especially you try to using the CCTV or camera. Okay, for some of the purpose. So I would like to say this is the very basic of the signal processing. So here's some of the conclusion for the chapter 2. Okay, I already show you that the basic idea of the sampling from the Nyquist frequency time truncation, right? And so please, you need to understand from the analog to the digital. Some of the very important you need to follow rules you need to follow. And right now we are showing the 3 R's. Your requirement, the project requirement, or the budget, limit budget. Okay. Here I would like to show you a very quick example of this data acquisition. Okay, so let me choose this one for the first. So it needs power supply. So this is a 12 DC. Okay, so if you cannot, you can get over here. Please help me to open this. 后面看不到的可以到前面来，因为我就只有一台。Okay. The first I would like to show you, because this is the PC. So right now, but this is the older version. Right now I have the newer version in the field. Maybe this is the device 10 years ago. So here you can find this is the module for the CF card. Anyone know this kind of the no? Okay. Okay. So I think maybe from the 10 years ago, this kind of the CF card is most popular for the maybe large space. But right now you can find here, this is only 1G, 1G of the disk. So this is the module. You can save the data of this flash disk. But right now, the newer one, we right now use the very small, the TF flash disk directly on the on this. Okay, and here, sorry. And be careful each time you try to put this kind of the power supply, make sure that the ground and the positive terminal. Okay. This kind of the data acquisition is very robust and durable. Okay, and if you try to using a solar panel for the power supply, it is very okay. Okay for the power using the power supply with the solar panel. Okay, and okay, so I already installed some of the program for this kind of the hardware, and this is the most popular, what we call the local net, but this is the not the free, not the free one. OK， 抱歉，再帮我把这个灯关一下好了。OK。So I think in the first you need to set up the how to connect to this kind of the data logger. Okay. So this is the wizard that you can directly choose the type. And here, okay, sure, sorry. We need to use the directly communication. So this is the IS-232, IS-232. But however, for now, in your laptop or in your computer, you cannot find any kind of the port for the IS-232. So we use the USB transfer to the IS-232. Okay, so this is our purpose, but make sure that connect before you try to set up. Okay, so here I choose the direct connection. Okay, and of course, for this kind of the module, you can use the different kind of the communication, like the modem, phone modem. I think have you ever listened the sound of the analog modem for the internet connection? Or maybe later I will show you. Okay, and also you can use the wireless. RF is the mean radio frequency from the very low, maybe 4 or 900 hertz of the RF. But right now we use the direct connection, and we use the COM7 because I changed from the IS-232 to the USB. Okay, and the next. Next. Oops. Okay, finish. And we also have the connect. No, not yet. Okay, there's a sum of a problem. Sorry. Okay, here you can find this is a screenshot for the communication with this data logger. And in the right side, it shows that the time of this computer, because this is maybe 10 years old, already 10 years old. So right now, the battery inside of this computer, the DAQ, is run off the battery. So we need to check and set the time. I mean the clock, the same with your own computer. And here I would like to show you in the middle of this table, some of the parameters list the status of this machine. Okay, for example, here. Okay, for this blue one, it shows that the temperature, because this machine, this data logger, have the maybe a temperature sensor inside, so you can detect the temperature. Okay, the panel temperature. And in the next, you can find the battery. Right now, I use a power supply for as the battery. Okay, so right now it shows that maybe 12 and 4982 DC. So of course you can change the traditional battery for the power supply. Okay, so here this is some of the very simple status parameters, and I would like to say here I already have the program inside of this data logger, but right now this is not so not run. Oh, sorry. So I would like to show you actually how the program it is. Okay, and maybe we put on my desktop. So this is the interface to check the connection for this data logger. Okay, and I would like to show you that if I try to have a program, how can we use that? CI, okay. I think this is the same with the Arduino program environment. Okay, so here you can find we need to claim some of the parameter first. Okay, for the public variable, temperature, the battery voltage, and we need to define a data table. Why? Because we try to store the observation data into the data table. And this table can be stored into the flashcard or transmit from the internet or the wireless communication. And here, this is the beginning of the main program. So you can begin the program and scan each second, and you can have several functions already built in here. This is all the function in the right side. Okay, so for this is the function that we need to try to capture the panel temperature of this DAQ. And this function is try to capture the power supplied voltage on the battery. Okay, and then we have a code table, means that after you already capture this data, and please try to write into the table, and also the CF card. Okay, CF card. So I think this kind of the program is very simple and very like the C language. And also I would like to show you some of the project actually apply in the field. I made by myself. Here, this is the full program. So I already claimed and declared some of the public variable. Okay, you can use the array and also the some of the single unit. And I have a lot of data table try to write. Okay, and this is the beginning of the program. So of course you can use the logic and the structure like the C or C++, if or else if, and while, and the do loop. Okay, so almost the same. Okay, but however, I think it is very easy if you try to understand. Oops. You can use the help for the very quick understanding of the command, or otherwise you can click the mouse of each function, and they will show you the function, the input parameter directly. So you can find here why we need to put these function parameters as the input. Okay, and also we will have a detailed example here. Okay, so for this kind of the program, I think it's very easy. Because they provide not only the description of the help, but also the example of the code, the code. Okay, so this is the basics of this kind of the DAQ. And the next, I would like to show you sorry, okay. I think we now move to the next. For this kind of the sense DAQ, we need to change the IS-485 protocol to the IS-232. So here, this module is the purpose for the protocol transform. Okay, so we use the IS-232 to connect to the IS-485. Okay, directly, and here we have A channel of this module. But before that, I need to also have a power supply first. So please wait. Oops. Power supplied here. Okay, right now you can see this is now on. Okay, and for this kind of the DAQ is very easy because we need just sending a command, and this kind of the DAQ will return the voltage or the reading of this A channel. But I would like to show you the basic interface for the communication here. Okay, right now, here you can find, this is the interface for the communication of this DAQ. But just as I said, in your last homework, you already know that what is the IS-485, the advantage of the IS-485, because you can use a single line to connect so many modules simultaneously. But however, you need to know that the ID, the identification of each module. So here, because right now we just only put a single one module, okay. And this module have the ID of number 1. Okay, so right now we click here, and you can find this is the sum of the setup for this kind of the data acquisition. And for the right side, you can find this is the reading from the A channels. So you can change the range by yourself. Okay, the minima range is about the 50 millivolt, and the maxima is the 2.5 voltage. Okay, because right now I didn't put any sensor on that. In the last time I said you can use a different kind of the sensor, right? Also you can buy your own one and can connect to this kind of the data acquisition to capture the signal from the sensor. So here, this is an example to show you that the reading from the A channel. Okay. So here, any problem? Later, maybe I need to go back and get the USB for your demonstration. So maybe we may have a 5 minutes break here. Okay. So let me go back for your